video is for Math 111 for the sample midterm. So I'm going to go over a sample test that's going to be very much like the test that you will see next week. So let's go ahead and get started. We start off with the first section that we covered a couple weeks ago. Simplification. We've got x minus 1 all squared minus 2 times x minus 5 times 3x plus 1. So really what we're working with here are two pieces, right? We've got one piece here, one piece here. So we want to simplify those separately and then look to combine like terms. So the first thing we're going to do is square x minus 1, and that means to multiply it by itself, and so we get x squared minus 2x plus 1. Then I'll multiply these two together, okay, these two parentheses, sets of parentheses, so we get 3x squared, let's see, minus 15x plus 1x, so that's going to be minus 14x, and then minus 5 on the end. And now we'll distribute the 2, so minus 6x squared plus 28x plus 10. And so now, like terms, here's our x squareds, here's our x's, and there's our constant terms. Okay? So, minus 5x squared, and then what? Plus 26x, and then 1 and 10 make 11, and there we go. That's the answer. Okay. Problem 2 is all about factoring and canceling. So let's see here. 3x squared minus 5x minus 8. X squared plus 5x plus 6. And let's see here. 3x squared plus 14x plus 16 over 64 minus 9x squared. Okay, so I think that these are easy to factor, because once you recognize that it's a difference of squares, then it's just 8 plus 3x, 8 minus 3x. A lot of people forget how to factor that. That's something you might want to write on your note card. Okay? So next, this one is a lot easier because it's got a 1 in front of the x. And all we need are factors of 6 that add up to 5. And so that's going to be plus 2 and plus 3. Now these are a little bit trickier because of that 3 in the beginning. But if you see these, well, for one thing, 3 is prime. You only have one choice for how that's going to split up. Okay? Now we need factors of 8 so that here and here we get a difference of 5. Okay? Well, 8 and 3 have a difference of 5. So here's the thing. If I put an 8 here and a 1 here, then minus 8 and positive 3 will give us negative 5 in the middle. I'll do the same thing over here, except this time we want them to add up and give us 14. So let's see, if we do 8 and 2 here, again, these are the multiplications that we're interested in that we want to add up and be 14. If we put 4 and 4 in there, you'd have 12, and 4 is 16. Is that right? 12 and 4 is 16. Yeah, because I was looking at 8 and 2, I thought that that was going to work as well, right? Because if I put 8 here and 2 here, then we get 6. Oh, right. Okay, so this is correct. So let me back up and try to eliminate the confusion. I added these up. 12 and 4 make 16. We need 14. That's not going to work. There we go. That's what was confusing me. But if I put an 8 here and a 2 here, 6 and 8 make 14, plus, and there we go. All right, now, x plus 2 and x plus 2 cancel. 3x plus 8 and 8 plus 3x are the same thing. They just cancel each other out and make 1. These two differ by a factor of -1. So when we cancel them out, They don't make 1. They make negative 1. Okay, now what's left? We've got negative x plus 1 over x plus 3. If you want to put the negative out in front, make sure that it's out in front. If you're going to put it up in the numerator or down in the denominator, either put parentheses or distribute the negative sign. Okay? All of these answers are correct. There's nothing wrong with any of them, but it's important that you do this correctly. If you just throw a negative out in front there, then that's not going to be correct. Okay, so there's problems 1 and 2. I think problem 3 is a common denominator problem. Let's see here. We've got x minus 3 over 2x minus 3 minus x over x plus 1. So we need to make a common denominator here, and it's just going to be each denominator multiplied by the other one, right? So let's see, this will be 2x minus 3 times x plus 1, and 2x minus 3 times x plus 1. So this one has to get multiplied by 2x minus 3 over 2x minus 3, and this one gets multiplied by x plus 1 over x plus 1. So, in the numerator, we get x plus 1 times x minus 3, and over here, x times 2x minus 3, and then we can just write it as one big fraction with a single denominator. Now, you can't cancel anything here. I know people really want to. It doesn't work. What prevents it from working? That subtraction sign right there. Okay? What we need to do is simplify and combine like terms in the numerator. So this will be x squared minus 2x minus 3 minus 2x squared plus 3x. And I'll just leave this thing the way that it is. Alright, so what are we going to end up with on top? Negative x squared minus 2x and plus 3x, so plus x, and then minus 3 on top, 2x minus 3 times x plus 1 on the bottom, and there we go. Okay? Not a lot of, that is lowest terms, is what I'm trying to say. There's no canceling that we can do in this one, because the numerator is not factorable. Alright, that's problem 3. Now, problems 4, 5, 6, and 7 are all equations. So let's take a look at these. X plus 3, 5 minus 2x equals 3 minus 5, x minus 2 times x plus 1. Okay, so we need to simplify. Over here, let's see, we'll get 5x minus 2x squared plus 15 minus 6x. Over here, don't fall into this trap. You don't want to do 3 minus 5. That's not how this works, okay? All of this multiplication has to happen before we do anything with this 3, okay? So I'll leave the 5 alone too, and this will be x squared minus x minus 2. And then it'll be 5x squared plus minus 5x squared plus 5x plus 10. Okay, so let's collect some like terms here. Over on this side, negative 2x squared minus x plus 15. Let's see, and then this one minus 5x squared plus 5x plus 13. I'll move everything over here. Okay. So, plus 5x squared minus 5x minus 13. That all cancels out. And over here, we get 3x squared minus 6x plus 2. Alright, so let's run it through the quadratic formula here. 3, negative 6, positive 2. And so x could be approximately 1 0.577 or 0.423. All right. There's problem 4. I think problem 5 is a cross-multiplying problem, yeah. So problem 5, we've got 2x plus 1 over x minus 5 equals x plus 4 over 2x minus 3. Okay, so we've got this set up. We've just got a single fraction equal to a single fraction. And so if we cross multiply, the results should be equal. So 2x plus 1 times 2x minus 3 should be equal to x minus 5 times x plus 4. All right, so now we're in a similar situation that we were in problem 4. This will be 4x squared. Let's see, minus 6x plus 2x, so that's minus 4x minus 3. Over here, x squared minus x minus 20. And so let's move everything to the other side. Minus x squared plus x plus 20. And so 3x squared, what is this going to be? Minus 3x plus 17. So we run that through the quadratic. 3 minus 3 and 17. Then we get x is going to be approximately 1/2 plus or minus 2.327i. And there we go. And don't forget the I on the end of your complex number, because without the I, it's not complex. Right? And then we've got 2 more equations to solve. Problem 6 goes 2 over x minus 7 plus 5 over x plus 1 equals 12. Now there are different ways to solve these equations. The way that I generally use or show in class and in the textbook, I think is the most straightforward way of doing this. If you've got other methods that are valid methods, there's nothing wrong with that. That's fine. Okay, so we're going to make a common denominator, and that's going to be x minus 7 times x plus 1. Okay, so this one gets multiplied by x plus 1 over x plus 1. This one gets multiplied by x minus 7 over x minus 7. So on top, we end up with 2 times x plus 1 plus 5 times x minus 7. And we've still got the 12 over here on the other side. All right, so I'm going to clear out this denominator by multiplying on both sides by x minus 7 times x plus 1. That'll cancel, and we'll get 2x plus 2 plus 5x minus 35. Over here, x squared minus 6x minus 7 times 12. So that'll be 12x squared minus 72x minus 84. Over here, 7x minus 33. Okay, so we're going to move everything over to this side, subtract the 7x, add 33. This will be 0. This will be 12x squared minus 79x minus 51. Okay, let's run that through the quadratic. Let's see, 12 minus 79 is B and minus 51 is C. And so our answer here, 7.176 or negative 0.592. And there we go. Okay, that's problem 6. Let's go on to number 7. 7. So another common denominators problem. We start out with 5 over x squared plus 7x minus 18 minus x plus 1 over x plus 9 equals x over x minus 2. Okay. So again, we need to make a common denominator. This thing, these are prime, this is factorable, it splits into this times this. Okay? So this is our common denominator right there. That fraction is not going to change. This one gets multiplied by x plus 9 over x plus 9, and this one gets multiplied by x minus 2 over x minus 2. So let's see what we get out of this then. This will be x times x plus 9 over x minus 2 times x plus 9. Don't cancel this because that'll just undo the common denominator you created. Over here, 5 minus x plus 1 times x minus 2 over x plus 9 times x minus 2, because that's what this is. Okay. So now we've got these two fractions equal to each other. They have the same denominator. So let's multiply on both sides by that denominator so that we can just cancel it out. So over here, x squared plus 9x. Over here, 5 minus x squared minus x minus 2. All right. So let's make a little bit of space here so we can finish the problem. Let's see. So this is going to be 5 minus x squared plus x plus 2 equals x squared plus 9x. All right, so negative x squared plus x plus 7 equals x squared plus 9x. And let's move everything over to this side. So that makes 0. Over here, 2x squared plus 8x minus 7. And we'll run this through the quadratic. A is 2, B is 8, C is negative 7. And that gives us x equals 0.739 or negative 4.739. Okay. Well, that's it for those ones. And we've got two more problems. These are from the beginning of chapter 2 here. So let's talk about these. These are those problems where you have to do solution by graphing. Let's see here. So, problem number 8. We've got 2x cubed minus 5x squared minus 7x plus 2. And we want to know, where is this greater than 0? So we're going to graph it. Let's see here. 2x to the third minus 5x squared minus 7x plus 2. Okay. And then we'll take a look at this on the standard window and see what it looks like. So there's a good look at what it looks like. I'll go and sketch that on the board, okay? And then I'll come back and find those roots using the 0 feature on the calculator. Okay, so let's see here. All right, so it's kind of doing that, and then it goes off the screen a little bit and comes back like that. And if we wanted to see this loop right here, we could extend our window down a little bit to open that up and see that. All right, but now let's go ahead and go through this process where we find these roots on the calculator, because these are going to be important to our answer. I think that's a good place for the calculator. Okay, so right, we want to do second trace, choice number 2, which is find the 0. So remember, it's going to ask you for a left bound. There's a good left bound. There's a good right bound. And the answer there, 1.181. So I'm going to go write that down. Okay. Let's see here. Okay, then we'll go through that process again. Second trace, choice number 2. Now we have to go out to the next one. There's a good left bound. There's a good right bound. And what is that? 0.247. Okay. And now we'll do the last one here. Let's see. Same process, second trace, choice number 2. Now we've got to go over to here. Oh, there's a good left bound. There's a good right bound. And there's the solution, 3.434. Okay. Okay, so those are our borderline points. Those are going to be a part of our answer. What we want to answer is, where is this thing, which we've graphed as y, where is y greater than 0? Okay, well, you can see y is greater than 0 here, and y is greater than 0 here. Okay, so it's we're going to have an open circle, since there's no equals to here. And it's going to be this region here, and then that region there. So that is x greater than 3.434, or x less than 0.247, but greater than, oh, that's a negative, negative 1.181. Okay, so that's number 8. Let's take a look at number 9. 6x to the 4th minus x cubed minus 12x squared plus 3x plus 1. And we want to know, where is that going to be less than 0? Okay, well, let's put that one in the calculator. So 6x to the 4th minus x to the 3rd minus 12x squared plus 3x plus 1. Double check I got everything right in here. And let's look at the graph. This one I will just sketch on the board and go in and find those roots. Okay. So let's see what we've got here. Got something like this, basically. Okay. All right, so let's go in and find where those roots are. That one, negative 1.425. Negative 0.192. Uh, 0.462. And 1.322. Okay? And then this one, we want to know where is y less than 0, right? Because we graphed this is y. We want to know where is y less than 0, there, and there, right? Because this is where y is positive, down here is where y is negative. So, where is y less than 0? So that's going to be this region in here, and this region over here. So, x less than 1.322, but greater than 0.462, or x less than negative 0.192, but greater than negative 1.425. Okay, so that's it. That's all that's going to be on your midterm. We'll pick up in Chapter 2 the week after the midterm. I'll get some assignments posted for you. Don't forget, when you come to the midterm, bring a graphing calculator, make sure you have paper, make sure you have a pen or pencil, and also you can have a 3x5 card, and you can write anything that you'd like on the front or back. As always, if you have any questions, please let me know. Thanks.